Okay, so let's do another multi-regression question here, which is um, major league ball for data. So first thing is go to open the data. Give you some time to open the file. Okay, let's come back to the question here. So first one, it wants to create a correlation matrix. It's a multi-collinearity a potential problem. So first we have all the columns except the column A with the numeric data. So we want to check whether there's a correlation between those columns in the data set. So let's go to the data analysis. This time, instead of using the regression, we will use the correlation. And your input range is the entire data set, just without first column. Label in the first row, yes. And output range, just pick a place to output here. Okay, so this is the correlation between all the columns, 2 by 2. Let's make the columns a little bit smaller so you can get a better view. Okay, so let's trick here to see all the numeric data. Select them all. Go to the home and condition formatting with color scales, more rules. And here we want to use the color to color out everything that is out from the 0.7. So we want to choose the second one, format only cells that contains, instead of between, we will say not between, right? We want anything that is less than negative 0.7 or greater than 0.7. And we give a format, click on format, choose a field, choose any color you want here, for example this one. Then okay. So it will label all the potential problem here, right? According to our lecture instruction, we should pick anything that is greater than 70% as a potential issue. So we have between runs and warm, runs and lost, right? But the problem here is one is what we want to predict for, so it's okay here. So we care about the runs between runs and home runs, right? And runs between runs and run batting or the home runs with the run batting. So those are the potential multi-collinearity problem for the model. Okay, so but the question didn't ask us to remove any of those, so we just include them all for now. But we have to remove the loss because they are the same thing here. They are the same thing here. You can see the correlation is -1, and usually when we do the analysis, we should remove any of those pair. Right? For example, let's say we either remove ran or home ran for the best performance of the model. But for here, the question asks us to just perform the same, right? So we want to remove the lost. We use all these columns to create a regression model. So let's do that together. So go to data analysis, regression. Okay. So input y is the 1. And input x, anything other than lost. And output range, pick 1. Okay. So let's do the same thing as the question 5. We find the p-value here. If you cannot see that clearly, we use home condition formatting with we can use a var, right? To see which one is the biggest. This one. This one has a problem with a p-value. Less problem in the t-test. I will still remove that for now. So we want to remove run binary. Because the regression only can put X together. You cannot say we do different areas, so we have to remove, cut this column to a different place. Let's leave it as don't use. And go back to data analysis, regression. Now we just change the X to this zone. Also, we do change the output here. Okay. Do that again. Do the formatting again. All right, this one is the triples. So remove the triples. Run the model again. Change X. Change output. So we need to repeat those processes until we get everything that is beneath the 0.05. And that would be your best model you want in this course. Okay, now it's doubles. So do that again. It's the exact same process until you find. You just cannot do them all. Sometimes the result is the same, but sometimes not, because every time you change your input, your model will change. Okay. Now within those, which is the biggest? Home run still greater than 0.05. So let's remove home run. Run the data analysis game. Change X. Output. So this one works. Okay, we don't have to move, just do regression, change X, change output. Okay, let's check that. Now everyone is within the 5%. Now everyone is within the 5%, so this is the best model. Best model we need. Okay, so there are some difference opinion between the suggested run hits and average strikeouts than the correlation model here. But you can see the importance would be very similar to each other. So this is question 6.